Hello everyone, this is me Kalam Hussein here, and I am going to present my Practicum 9 of Max, second semester here, and this is the overall code which I have been presented here, and that's the output given below, and I'll present it to you with a full explanation here. Which this topic is about Laplace transform, and we shall go with the steps on to the first step, which is to import symbolic mathematical library, which is sim pysp, and on to the second step, which defining symbolic variables. T comma s is equal to sp dot simples, in bracket ts is comma real is equal to 2, positive is equal to 2. And on to step 3, which is define workload signals, exponential decay workload, auto scaling stabilization. And we are defining it as f1 is equal to sp dot exponential minus 2t, and onto the periodic traffic spikes, the scheduled API calls, so which is f2, and we are taking as sp dot sine phi t, and onto the next one, third one, and which is gradually increasing traffic RAM growth. F3 is equal to T, and on to the step 4, which we are storing signals in a list, which is signals is equal to F1 comma F2 comma F3, and on to the first step 5 and 6. We are computing Laplace transform for each signal and displaying results for I comma F in enumerate signals. Start is equal to 1. For I comma F in enumerate signals comma start is equal to 1. F is equal to sp dot Laplace transform F comma T comma S no comes is equal to 2. True. And we are printing out the signal f of it is equal to uh, the output, and we are defining it through f and small f, and after that we are defining the Laplace transform capital F I comma s is equal to and capital F, and after that we are interpreting the conclusion, and printing out the RAM type workload is most critical for system stability. And onto the output here, which we have determined for, onto the first one, signal f1, which is f of I t is equal to exponential minus 2t. The Laplace transform which we have occurred is 1 by s plus 2. And onto the second one, which we have obtained is sine phi t, which is in Laplace transform, which is phi s square plus 25. And onto the third one, f is equal to I f I t is equal to t, and the Laplace transform is s to the power minus 2, and we are interpreting the conclusion such as a RAM type workload is the most critical for system stability. And there you go. This is the overall output which have occurred for the three types of signals which are respectively f1, f2, and f3. And f1 is for exponential minus 2t, which is 1 by s plus 2, and for f2, which is sine 5t, which is 5 by s square plus 25. And on to the third one, which is t, which is derived as s minus 2, s to the power minus 2. These are all derived using the formula. Okay. And for example, here sine phi t has been derived in a way we can determine as sine of at, which is equal to a square plus a square. A square is by s square plus a square. We are here, a has been determined as 5, so the value has been occurred as 5 by s square plus 25. So there you go. This is a basic example for the formula for which have been applied here, and this is the overall output which have occurred for the overall output which I have obtained here. And there you go. This part is the overall code which I used to determine the values, and this part is used to determine the signal values and the Laplace transform for three parts of the equation. And in conclusion, we are determining that AMP type workload is most critical for system stability. So there you go. This is the overall. Or that's it. Thank you.